All right. So first of all, I just want to tell you that a couple of things already are given. Some constants, few things, so you should be aware of this. Throughout the course, you've learned this. And then some of the formulas are given. Most of them won't be used, but some notable formulas are this one. And well, somebody, this one, and this is important in AS. Otherwise, other formulas are all right. Now, for the very first question, they said which is vector, which is scalar. So naturally, acceleration is vector, power is scalar. Keep checking your work, please. And this is scalar. So you get 2 marks here. Then in the next part of this, they said determine the acceleration object from this to this. So from this point to this point, you should know that acceleration is the gradient. So you could find v minus u upon t. So the initial velocity is right here. If you really don't know how to, put this here, what you do is, because if you look at it, 0, take the change between the values like this. This will be 0.25. And then they're divided into 5 small boxes, like you can see here. So there's 5 divisions, so you divide by 5. This will be, I believe, 0.05. So this means that what we're looking at is 0.70. And here it is going to be 1.30, 1.35, 1.40. So you can use this. So 1.40 minus 0.70 divided by the difference in time is from here to here. That's 4 seconds. So let me take out the calculator. And then you do . So that is 0.175. Now, I just want to tell you this. All right, well, it's writing 0.175, all right. But because in our data, the minimum significant were 2, so it would be ideal that you follow the same rule of writing 0.18. All right. Now, let's go to the next question. If you feel that you need to ask any question in the middle, please let me know. Hashim, please mute your mic. Now, going to this, it says determine the distance moved by an object from this to this. Okay, so if you look at this, we should understand the distance is area under the curve, and area under the graph is from here till here. So this makes a trapezium, all right? So this is 0.7, that is 1.4, and we have this. So easily you can do this area equals to half times the height was 4 times the sum of parallel sides is this one and this one, which is 0.70 and 1.40. So you add that. So when you do this, so you should be getting around 4.2 meters. Check this, please. It's not very hard. Now in part C, it says define force, and force is basically rate of change of force. Hashim, can you please mute your mic? So all right, so basically it's a rate of change of momentum, and then it says the motion represented by figure 1.1 is caused by resultant force F acting on an object. It says sketch a graph, sketch the variation of F at time t between this, and numerical values are not required. Now, if you look at it, you should see that initially there is constant acceleration. Constant acceleration means that between 0 to 4, the line on this should show you a constant value like this. Whatever you want to make, it doesn't matter. But let's to change, let's make it a bit down. I just want to tell you why. And then in this section of the graph, you see the acceleration is 0, which means that force is also 0, which means that this line is going to go down. And for, I think, how much time that was? Around 8, it is going to stay 0. And then in the last section of this is like a straight line down. But if you look at it, it's much steeper than this one, but it is negative acceleration because the line is going down. And whenever you point an arrow that goes down, do understand that the gradient is 0. So it should be negative value and larger than before, so it should go down. And it is constant because it's a straight line. So it would look like this. If you still have any questions, please let me know. All right. Now, then it says state what is meant by work done, and it has a very specific definition. You write that force times displacement, but make sure you add it to this line that in the direction of force. That should be written. Now in this one, it says a beach ball is released from balcony of a tall building. The ball falls vertically from rest and reaches a constant terminal velocity. The gravitational potential energy of ball decreases by this as it falls from balcony to the ground. The ball hits the ground with speed this, the kinetic energy this. Show that the mass of the ball is this. No, that's fine. Right now, as you can see, that you have the kinetic energies and you have the final speed, so you can easily use kinetic energy equals to half mv square. Kinetic energy is 23. This is 2. You got to find the mass, and the speed is 16 whole square. Now let's take out the calculator. So this will be 23 times 2 and divided by 16 squared, which is 0.179, which is 0.18 kilograms. So that's shown right here. And then it says calculate the height of the balcony. Now, since you have the mass, you can easily use mgh for gravitational potential energy. The mass is 0.18. This is 9.81, as you know, g. You got to find h. And they told you that the loss is 60, like this. So you got to do this now. In case, let's suppose you don't, you were not able to do the first part, do not worry, because this has to be 34 meters. Okay. If you do not end up doing this, please use this value because only 2 marks will be detected and you will still get the marks ahead. So do not skip the whole thing. And then it says determine the average resistive force acting on the ball as it falls from balcony to the ground. Now you know that basically the work done against air resistance is the difference in energy, because if there was 60 joules of GPE, it was only converted to 23 joules of kinetic. So the rest would be the work done that is done through this. So that would be 37, I believe. And then you already know that you have the displacement right here. You can use work done equals to force times displacement. The work done is 37. You got to find the force, and that is 34. So force is going to be 37 divided by 34. So that's 1.1 newtons. Okay. If you have any questions, anything you would like to ask, anything you did not understand, please let me know. Right. Okay. Now you go to the next part. It says that state and explain the variation, if any, in the magnitude or acceleration of the ball in B. That is, okay, the whole thing. During the time interval when the ball is moving downwards before it reaches constant terminal velocity. Now, this is actually asking you how it reaches, basically what is happening to the forces. So remember, you got to write that as the speed increases. Now, I'm writing for all 3 marks. I'm going to number them so that you guys also, know what is required. As the speed increases, right, air resistance increases as well. Now, if you want to know how I'm writing this, you should look towards the notes. Today, I'm going to post all the notes that we had previously done, so you can actually go through them once again. Now, the second part would be that since weight is constant and acting downwards, and air resistance increases upwards, right? So because that's what we go right. So resultant force decreases. Now, because it makes sense when the resultant force decreases, so we can write, hence, the acceleration acceleration decreases as resultant force equals to ma. So that would give you 3 marks. Be very careful. And it's always nice to write in points so you already know that what you've missed, right? Now, the next question now, question 3. Now, in this question, it says state the name of law that relates force and extension to the spring. So because this is straight line, so I'm going to say it's the Hooke's law. Now, it says determine spring constant in Newton meter of the spring. Now, you can take any 2 values. If I were you, I'd just take this because this is 7.0 and this is 5. Now, the only thing is you guys need to remember is because force is equal to kx, the force I took is 7, but the x is in centimeters, which is 5. So what I'm going to do is I'm going to change it into meters like this. Now 7 divided by 5.0 times 10 raised to minus 2. So let's do it quickly. Using this function in the calculator lets you make less mistakes. So make sure you get one with natural display. So that's 140. Now, it says strain energy elastic potential when the spring is extended is 4 centimeters. So we're going to go here, right here. Now we have this 4. So because, sometimes you can also find it using the force, like you can get the force from here and then find it, but it will be long. So instead of using this, if I were you, I'd use half into kx squared. That is much easier because you already have found this. Or you can, if you still like it, you can use half force into x, but that's up to you. So if you haven't been able to do the first part, then you should definitely stick to this one. And 4 centimeter means I got to change it into this and whole square like that. Now let's do this. 0.5 times 140 times 4.0 times 10 raised to power minus 2 and whole square. So this is around 0.112 joules, because all my values are in two significant figures, like the minimum one. So I'm going to just write it as this. Well, this is also correct. So even if you've written 112, that's fine, right? Now, going to the next part. Now it says that cylinder has a length 5.8, cross-sectional area 1.2, and weight is this. Cylinder is in equilibrium and the extension is this, right? Show that the upthrust acting on the cylinder. So we already know that the weight of this is going to be downwards, right? There is going to be some tension in this, and of course some upthrust is going to be acting too. So right now what we're going to do is we are going to find the tension that should be there. So our principal equation that basically works like this is that weight should be equal to upthrust plus tension. So upthrust should be equal to weight minus tension, like this, right? Now, let me take out that. I think we already have that. They have given us something. The cylinder has a length 5.8. Okay. And cross-sectional area, the weight is this. The cylinder is equilibrium when the extension is 4. If the extension is 4, then what we're going to do is we're going to go here. We're going to check what is this. So if this was 5, this is 5.2, 5.4, and 5.6. So I'm gonna add this like this. This would be 6.20 minus 5.60. So that should be, according to my mental math, should be 0.60 newtons, and that is what we have shown. So that's great. Now, if you did not understand how I got this value, please let me know. This one. All right. Now, it says calculate the difference in pressure between the bottom face and the top face of the cylinder. It's pretty easy because we already have the upthrust, and upthrust is the difference of pressure. So what we're going to do, we know that the change in pressure would be equal to change in force over area. The change in force is 0.60, and the area is, I think, this one. 1.2 times 10 raised to minus 3. Let's do this. Okay, so it is 500. So I'm going to try 500 pascals. Please let me know if you have a question. All right. Then says calculate the density of the liquid. We know that pressure is rho GH. We have found the pressure, which is 500. We got to find this. This is 9.81, and the height. I think they gave us the height of the cylinder already, which is 5.8. So I'm going to put 5.8 times 10 raised to power minus 2, and then the density. Let's quickly do this. So 500 divided by 9.81 and divided by 5.8 times 10 raised to power minus 2. So it's almost 879, right? So 879 kg per meter cube. All right. Now it says a liquid is replaced by another liquid of greater density. State the effect. Now, if you look at it, the upthrust, basically upthrust is given as rho g delta v. So upthrust basically depends on density. So if the higher the density, the upthrust will be more. So we're going to write it will increase, increases, and extension of the spring. If there is more upthrust, then it will actually pull it upwards. So the extension will reduce. Please let me know if you have a question now. All right. Now moving towards the next question, which is a principle of superposition. So this for 2 marks, please write that when 2 or more waves meet at a point. So this should be the first mark. The second mark should be the resultant displacement is the sum of the individual displacements at that point. Right? You can write it. Now, there's a metal plate. We have already done this experiment. So if you want to view it again, go back to the notes or the recording. It says the microwaves have this blah, blah, blah. Anyway, explain the function of the metal plate. So of course, metal plate is there for reflection. So we're going to write it is a reflector of the wave. Now it says calculate the frequency in gigahertz of microwaves. Now this is basically a question about, they have given the wavelength already. So we're going to use V is equal to F lambda. We should know that the speed of any EM spectrum wave is this. Sorry. And frequency lambda is 0.040. So let's do this. All right, divided by 0.040. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 means that all right. Okay, so 9 means 7.5 times 10 raised to 9. 9 is already, giga. So it means this is gigahertz. I'm going to write 7.5. Now, in the next question, it says the microwave receiver is initially placed at point X where it detects an intensity minimum. This means this is a node. And then the receiver is then slowly moved away from X directly towards the plate. Fine. Determine the shortest distance between X of the receiver when it detects another minimum intensity. Now, you should remember that between a node to a node, the distance is equal to half lambda. Now, the lambda in this question is 0.040. So the answer would be 0.020. Right. Now it says determine the number of intensity maxima that are detected by receiver as it moves from position X. That is 9.1 centimeter from this. Right. Now you already have node to node distance, right? So what you do, you divide this. I don't know whether this is in meters or what. This is in meters, right? So this would convert this into centimeters. If I convert this into centimeters, that would be 2.0 centimeters. You divide that. Now, when you divide that, 9.1 divided by 2.0, it comes out to be 4.55. You round it off, right? that is almost 5. So because why am I rounding it up? Because whenever we count, right? So there's a node and then we call like 1, 2, we count it like this, right? 3 and 4. But if we count this one, then basically from 0, there are 5. So that's why it has to be 5. All right, do remember that. Do not be tricked by writing just 4. If you have any in the, right. So Suman, basically, if you look at the answer, right? So I've already always told you that you need to basically, even if it's 4.99, you got to write it as 4, right?
Yes, sir.
So because when you count, right, you start from this node, there were minimums. So you count 1, 2, 3, 4 like this, right? Because already you're counting distances, so there has to be 0 here. So the total number of nodes would be 5, but the total lambdas that we have counted are 4. You can count 1, 2, 3, 4. Do you see?
Okay, sir.
So by dividing by lambda, it means, or the distance. So this is half lambda, this is half lambda, this is half lambda. So basically we have found how many half lambdas were there. So there are 4, but how many nodes are there? There are 5, because we should include the 0th one as well. Understood? That's why. All right. So
Sir?
moving to, yes.
What formula did you use here?
No formula. I just said if half lambda between node to node, right? So node to node distance is 2.0. So how many node to node distances are in 9.13 cross multiply? It's a ratio.
Oh, okay. Okay.
Do you understand? That's
Yes.
how I found it. Anyway, so going to the next one then. Question number 5. A source of sound is attached to a rope and then swung at constant speed, right? So all well, what I do is in my exam when I'm solving, I just add, underline the things that I think would be important. Now it says the source moves with the speed of this and emits a frequency of this. So I should know this. This is the speed of source, and this is the frequency of source. The speed of sound. So this is the speed of sound. An observer standing a long distance away from source. Calculate the minimum frequency to this 3 significant figure heard by an observer. The minimum frequency would be when this object is moving towards the observer, because at this position it will move towards the observer. In this position, it is going to move away from the observer. So I should think, right? Now, whenever something is moving towards the observer, we have the formula. The frequency observed is Fs times V, and V plus Vs. Now, when you go back, so let me just quickly go back to tell you a small thing. So in the start of paper, I highlighted this. There is plus minus in this, right? In this formula. So you can check this out. So you should remember that plus is when it is moving towards the observer, minus is when it is moving away from
Sir,
the observer.
isn't plus away?
Towards, no, not away. Yeah. Sorry. Yep, my mistake. So it should be, it's moving towards, but it says find the minimum frequency. Minimum frequency means that it needs to go away now. Do you see? So because when something is moving closer to you, frequency, apparent frequency increases. When it is moving away from you, so it decreases. So closer increases, away decreases. Do you understand the whole thing? So
Okay.
now that's why I put plus here. Now what I do, I'll just, this is 951. The speed of sound was 330. This was 330 plus 12. So let's do this. And then 330 plus 12. This would be 917, almost 918, right? So I'm going to write 918 hertz. So that would be the minimum frequency he's going to hear, because I took it when it was going away. And then circular path of the source has a radius of this, right? Determine the shortest time interval between the observer hearing sound of minimum frequency and the maximum frequency. Now, this is something very, very important, because as you know that basically this is a circle, right? So if you make a circle, let me make a circle. Oh, yeah. From here, right? So at this point, it would be moving towards him, and this is when he's moving away from him. So between this, as you can see, this whole thing should move from here till here between this time, right? All right. Now they have given the radius. I think the radius is 2.4. So this is the radius, right? And they want us to find the time interval. So we already know that time is equal to distance over speed, right? So I think we have the speed that is 12, right? So, but the point is, how do we find the whole thing? So, okay. So the distance it would be moving is the semicircle one. So you guys know what is the formula for a circumference? It is 2 pi r, right? This is for whole circle. And for a semicircle, it should be pi r only. So what I'm going to do, I'm going to multiply pi times the radius divided by 12. That should give us the time. Let me see.
Excuse me, sir.
Pi. Yes.
सर आपने पाई आर क्यों लिया 2 पाई आर क्यों नहीं?
Because it's only half the circle. It is half the circle. Between this point, when he hears the maximum, and this point, it has to move only this much. So it means that this is half the circle, not the full. That's fine. You see?
सर ये वाला थोड़ा सा एक्सप्लेन कर देंगे?
So if it moves from here and back here, so this is half the circle, right? Like you see, when the object is exactly moving towards the observer, it is at this point. When it is moving away from the observer, it is at this point. So from going from this point to this point, how much distance will he cover? Won't it cover only this much? That constitutes the half circle. Do you understand this?
Yes, sir.
And then, of course, you have to find what is the circumference of a half circle. So that has to be pi r, because for a full circle it's 2 pi r. Okay, is it clear?
जी sir.
So this means it is 0.63 here. Do you remember that? Now, then question number 6. Now it says Kirchhoff's first law. So first law is the current one. So you should always write that sum of currents entering into, how much marks is this? 1, right? Entering into junction equals sum of currents exiting the same junction.
Excuse me,
do-
sir.
Yes.
सर हम ये भी लिख सकते हैं ना, मतलब एंटरिंग इनटू, मतलब जिस पॉइंट से एंटर कर रहा है उसी पॉइंट से वो लीव भी करेगा.
Yeah. You can write leaving here if you want to. Same word. Okay. Now,
Okay.
if you look at this, they have given you a graph, and then they say determine the resistance of the lamp in figure 1.6.1. So they have given you the characteristic graph of the lamp already. If you look at it, there is 2.1 current going here. This is entering. So here the current is going to be 3.6 is entering, and then this should be X plus 2.1. So X is going to be, I think, 1.5, right? Ampere. So that should be 1.5. Now what you do, it says calculate the resistance. So for resistance, we must have the voltage, and the graph is given. So I'm going to go to 1.5, check this, and then I'm going to go and check what is the voltage at this point. Now, as you can see, this is 5. So this should be 4.2, 4.4. So at this current voltage is this. So current is 1.5 and voltage is 4.4. So V is equal to IR. R would be 4.4 divided by 1.5. Okay, so 4.4 divided by 1.5. That would be 2.9. 2.9 ohms. Now it says determine the internal resistance R of the battery. Now if internal resistance needs to be there, like you can see the graph. All right, not a bad way. Okay, so right, tricky, huh? Now check this out. To find internal resistance, we know the equation is EMF equals to I load resistance or IR, like this, right? Very simple. Now what you do, as you can see that this is EMF is 12 right here. On this lamp, so we're just taking this loop right now. Check this. So in this lamp, the voltage across this lamp we found out was 4.4. So it means this is 4.4. And we know that the current that was going through this would be 3.6. So we're going to write 3.6 times R. So now it will be 12.0 minus 4.4 divided by 3.6. That is going to be R. Let me just use the calculator. 12 minus 4.4 divided by 3.6 is 2.1. So it should be 2.1 ohms, right? Now, if you do not understand something, please do let me know how I got this equation or whatever, right? Now, in this, the next question is the initial energy stored in the battery is 460 kilo ohms and the 470, sorry. Assume that the EMF and the current of the battery do not change. Calculate the time taken for the energy stored in the battery becomes 240. Now, this is something, you know. Okay, so it says the initial energy is this, and calculate time taken stored in the battery to become 460. So how much basically energy is lost is 470 kilojoules minus 240 kilojoules, right? First of all, I'm going to look at it. This, I think, let me just do it, 470 and 240. This is 230. So 230 kilojoules is basically gone out, right? So I'm going to write it as 230 times 10 raised to power 3, because this is kilo, right? My God. 3. Okay. Now, this is the energy, and we need to find the time. So we have the, right. We need to find the time. Great. Let me think. What should we do to find the time? Okay, no worries. So what we can do is, we know that the only way to find time is that if I could use current equals to charge upon time. And to find the charge, yeah. So I have the energy, I need to find the charge. and the voltage doesn't change, right? So the voltage of the battery was 12, right? So what I'm going to do is I'm going to use energy equals to V upon Q. I got to find this charge for some reason. That's for sure. So this is 12 and energy was 230 times 10 raised to 3, like this. So this is a tough question, really.
Sir,
Yes.
sir, VIT नहीं use कर सकते?
VIT.
Yes, sir. E equals VIT.
हाँ वो भी use कर सकते हैं. You're right. You're right. You're right. Let me check if I could get the same answer from this and that. What do you say? Can I?
Okay, sir, sure.
Okay, this is for only, you know, my own learning. Okay, so I'm going to put it here. And the current was 3.6, I think. Oh, maxing check. Yeah, it's 3.6. And divide by time. So time should be, yep, 12 times. ये कुछ गड़बड़ हो गई. I don't think so. This is correct. Charge goes there. Voltage over energy. That's correct. It's charge. ये गलत हो गया. It should be VQ, not this. Times, sorry, this should be basically 230 times 10 raised to power 3 divided by 12. Sorry, 230 times 10 raised to power 3 divided by 12. And this was 3.6. So 230 times 10 power 3 or 12 times 3.6. Let's check this and then from that as well, whether we can get the same answer. I think you're going to get the same answer. And that's one. Divided by 12.
Yeah,
Divided by
the same answer both ways.
yeah,
Even if
Hannah?
Yeah.
That's great. So 5324. Now I would not advise writing this much because all of my values are too significant. So I would write it as 5300. Okay. So even if you use E is equal to VIT, that would also work. But I think this is harder, my method. You should use this. It's the same thing. Anyway, now then going to this one. It says filament wire of lamp is connected in series with adjacent copper connecting wire and cross-sectional area. Oh, they have already given the table that I taught you. So it says calculate the average drift speed of free electrons and the speed of free electrons in copper wire. Right. So that's not very hard, you know. So you should know that I equals to NAVE, right? So this is the formula you should always remember. For first of all, I'm going to find for the filament, right? Filament N is N, A is A. We got to find VF and the free electron, the charge electron is the same. For current they have the same current. Okay. Because they're in series. Okay. So they have 2.5 N. Area is 360 A. So I'm making 2. This is for filament. This is for copper. Filament is tungsten, by the way. Okay, then we need to find velocity in copper and E. Now what you do, they say filament over this. So basically you just divide this. So when you do divide, no. First, don't divide this, sorry. We need to make this the subject. So velocity in filament is equal to I over NAE, and velocity in copper is I over 2.5 N times 360 A times E. Now you divide it. How do you divide it? So basically you write it like this. It is easier this way when you just make one more step, like put this sign, put it here. If you're smart enough, you can just take reciprocal ahead of time. That doesn't really matter. So when you take the reciprocal, so this will be 2.5 N times 360 A times E over I. I and I cancel out. N and N cancel out, A and A cancel out, E and E cancel out. So ultimately, you are left with VF over VC as 2.5 times 360. So that would be 2.5 times 360. That is 900. So that would be it. If you have any questions, please let me know. Then going to the last question. We are only left with 15 minutes, so I hope you can do it. It says, result of alpha particle scattering experiment provides evidence. Fine. Result one is vast majority of alpha particle pass straight through or are deviated small angles, and the result two is a small minority scattered through alpha bar greater than 90. Greater than 90. Okay, it means they come back, right? So if this is something, just write. For the first one, I've written this, so you should now remember this. Most of the atom consists of free space. So if you still haven't learned this, this is not fair, you know. And then in the first, in this part, you should always understand that the nucleus has all the positive charge for 1 mark. And for the second mark, you should write that all the mass is concentrated in a tiny nucleus. All right, so do remember that. That's the second mark. Well, this seems pretty easy to me. It says there's a decay and determine the proton number of S. So there was, you can see. Oh. Nucleus S is an isotope of P. The radioactive decay sequence contains 4 nuclei, P, Q, R, S, right? And there's no other information given, right? In this, I can see there's an alpha particle. Why? Because it is 4 down and 2 down. In this, I see a beta particle. So S should be actually, I don't know, they haven't written anything. Let me see. Nucleus S is an isotope of P. If it is an isotope of P, it means that it should have the same number of neutrons, same number of protons, sorry, and different number of neutrons. And that could, yeah, and same. So the nucleon number should be 1 up and it should be 214. It means it gives a beta particle as well. Like this. Do you guys understand what I did here?
सर दोबारा समझा दें.
It says nucleus S is an isotope of P. So this P. What is isotope?
So same proton and different neutron number.
Same proton number. So we know that it should be 84 here, right?
Yes.
How would this be 84 from 83 if a beta particle was added to it, right? I mean,
Yes, sir.
so and the mass would be the same.
Okay,
That's
sir.
Right? Now, it says the core composition of a nucleon in Q changes as Q decays to form R. Okay. Describe this change to core composition in the nucleon. Now, if you look at it, there is an increase here. How could that be? Think about it. So Q, which was 214, 82, going to R, which is 214, 83, it must be if a beta particle would have been released as well, right? You guys understand
Yes.
this? Now, this is all, rote learning. So this is beta negative. So you should always remember in beta negative, a down quark changes to an up quark. This is what they're asking. Okay. Now, in case you still forget, you're like, oh my God, what do I do? I'm stuck. right? So you should remember there's a anti-neutrino here, and then what you do, you check the number of new protons, So if you can see, there is one neutron which is going to one proton like this, and a beta particle like this. You can check, like there were 82 and now this is 83. So it means, and this neutron reduces, which means one neutron goes here. Neutron is up, down, down, and proton is up, up, down, and this. So you can, now you know that it's basically down goes to an up, because up, down is the same. So you can always, work it out if you are stuck. So I hope you guys have some understanding of this paper. And it is not nice if you haven't done anything.